Welcome everybody, right on the dot. You like that timing? Welcome to Programming 101. We're going to learn how to be a better programmer, and we're going to do it by making a Minecraft game. I'm going to switch over to this thing. We're going to be making Minecraft, not actual Minecraft. We're going to be making a Minecraft knockoff, and we're going to be using Java to do it. We're going to be using JMonkey Engine, which I've talked about before. If you don't have JMonkey Engine or JMonkey Platform, what you can do is you can open up Google, type JMonkey Engine, and jmonkeyengine.org is what you want. They also have an IDE, which is an integrated development environment like NetBeans or Eclipse. In fact, their IDE is actually NetBeans, but with added plugins and features and stuff. So you just go to their website, you hit downloads, and you download one of these things, whichever is appropriate for your machine. It comes with the IDE, it installs the JMonkey Engine libraries, and then all you got to do, let me get rid of that, all you got to do is you open it up, and you right click up here in the Projects tab, which should be on the top left if it's new, and you hit New Project, JME3, Basic Game. This is what we're going to start with. It has a bunch of other templates for other types of games. One that is very important, I guess, one that makes things easier is called an advanced game that uses game states. And what a game state is you basically have many miniature games, like miniature engines inside your game that you can switch on and off at any time. So you would use this, for example, you would have one game state for maybe your login menu or your start menu. You'd have a game state for the actual game. You'd have a game state for character creation, things like that. We're not going to have any of that. We're just going to have one engine, so we'll make a basic game. We're going to call it YoursCraft. That is so stupid. I just thought of that and it's amazing. Alright. We're going to call it YoursCraft. Not Minecraft, but YoursCraft. And it gives you a few things here. Let me actually close these projects because we don't need them and they take up space. Can I not close 3 projects? So they should go away. Awesome. I'm going to make this a little bigger so I have more room. And what it starts you with is this class called main. As you may guess, Norman Hansen made the template for this class. He's one of the guys who works on JMonkey. And it comes with this basic code. I'm going to run it, and this is what it looks like when it runs. Hopefully the stream will pick this up. It does. You get to pick your resolution, which I'm going to make 1280 by 9720, one of these, that one. And the rest of the stuff is fine. And we get a blue box, and we have basic controls. This is what you get when you start a JMonkey Engine project. You get some basic controls, so I can move the camera very slowly with the WASDs, and I can move the mouse where the mouse is looking with the mouse, where the camera is looking with the mouse. Guys, did you know that the mouse can move the mouse? Because that's high technology right there. This is all you get when you start a new template. So what we're going to do is we're going to get rid of this. This is what creates that box. So basically this is what we're left with. This is all you need. Let me get rid of these imports. This is all you need to just run the engine, and if I run it now we'll get a blank screen with some stats in the bottom left. It's like number of triangles. I don't know if you can see it on stream. I don't know if the text is too small, but it's got like number of triangles, number of textures, frame buffers, things like that. So I have done some videos on JMonkey. Actually, I think it was just one or maybe 2. But I'm going to very briefly describe how a game, any game engine, not just JMonkey Engine, but how any game engine works. So the simple init app, this runs when the program starts. Simple update runs after every render frame. Simple render happens before every render frame. Okay, so we're not going to be using simple render because that's for really advanced stuff that you don't need in most games. Some games you do, but in this one you don't. So in fact, I think we can just get rid of it because it's an override anyway. Good, we don't need it. So we're just going to have simple init and simple update. These are the only 2 methods we're going to have. I mean, we're going to add a lot more, but these are the only 2 that the engine actually uses. We're going to have other methods called within them. So we're making a Minecraft game. The first thing we need to do, well, there are a lot of things we could do first, but the first thing that I'm going to do is just create some objects. One object I'm going to need is a block. So we're going to create an object that represents a block in the world. So if you haven't heard of Minecraft, shame on you. It's very popular. I don't actually play Minecraft. I have 7 Days to Die, which is very similar. It's the same thing. But anyway, so Minecraft is basically this giant three-dimensional grid of cubes. And you can destroy the cubes and pick them up, and then you can place them down anywhere else in the world. So you basically mine the world of resources, and then you build stuff. You can build houses and castles and that kind of thing. Which sounds really simple, but it's actually kind of fun. So this is going to be block. And I'm not going to make separate packages because we're only going to make the bare minimum needed to do a functional Minecraft. All we're going to have the player able to do is move around, mine blocks, and place blocks. That's all we're going to go for. And this is probably going to take multiple episodes. I'm not going to finish all of this today, but we're going to get the basics down. I never got rid of my templates. Oh, screw it. All right, block. So what do we need for a block? Well, we need a position. And because the world is it's a grid of cubes, we don't have to represent where these blocks are with floats. We can represent it with integers because they're always going to be in the same distance away from each other. So x equals 0, y equals 0. We could make those private. Let's make them private. That's good practice. Make all your things private. Generate getters and setters. Generate getters and setters. It's different in NetBeans, isn't it? Complete code. Generate this and this. Oh, I have to do it one at a time. That's pretty lame. Complete code, control space, get y. Okay, public block int x int y. This is going to be our constructor, so every time we create a block, we don't have to use the set or get functions to we don't have to use the set x or get or set y functions to set where it is. We can just tell it this x equals x, this y equals y. Do this. That's the wrong key. Do this. All right. I need a set x and set y. Actually, no, I don't. The blocks never actually move. We can remove them. We're going to need to know where they are, but we don't actually need to set the x and the y after they're already set. So I think that will be fine. Yes. That's what I want to do. So the other thing we're going to need is the world. We're going to need the grid that contains all these blocks. So how about block grid? I could call it anything, but I'm going to call it the block grid. And we're not going to make our world super huge. Minecraft and games like it have worlds that are procedural, which means you don't actually, well, once you start a world, you load from a file, but when you create a world, it's procedural, it's generated. So we're not going to have a world that's infinitely generated. We're going to have a finite world because it's easier to code. It'll take way less time. So our block grid is going to be 3 dimensions. Did I do that right? Yeah. 3-dimensional block array. Blocks equals new block. So now we have a 3-dimensional array of blocks. Public void public, it's going to be a constructor, block grid. And we'll be able to say how big our world is going to be. So x, y, and z. I don't even really need to do a z. Let's keep it in there anyway just to make it flexible. So what we're going to do is for int I equals 0, I less, oh actually there's one more thing I want. Int, what am I going to call? So originally my algorithm, actually let me write the algorithm first. I is less than x, I plus plus. For int y, I, j equals 0, j less than y, j plus plus. Oh, and the coordinate system I'm going to be using, by the way, is the actual 3-dimensional coordinate system. So x is side to side, y is up and down, y is elevation, z is back and forth. So x and z are going to be the plane of the ground. The flat ground is going to be x and z, y is going to be elevation. We're going to have another loop in here. This is going to generate all the blocks. Int k equals 0, k less than z, k plus plus. That braces placement is triggering Wraithy's I learned this using old scripting language like Neverwinter script for Neverwinter Nights. This is how the community did braces in Neverwinter Nights, and that's just how I got used to it. At work, I have to do it the way that most people are used to, which is you put the braces at the end of the line of the loop, and you put the closing one on the same column as the keyword, like this, for this loop. That's how most people do it, but I actually like this way. It's easier for me to see because that's what I'm used to. Anyway, so we're going to go through X, Y, and Z. Y is going to be the elevation. So what I'm going to do is, let me do this first. Blocks X, Y, Z equals new block. Oh, we're going to need one thing on block, though. We're going to need the type of block. Private int type. I could make this an enum, but I don't really want to. -1 is going to be air. I'm defining it's going to be air just because. I don't know if it's GNU convention. If you say so, I'll believe you. But I just learned it from the past, and that's what I'm used to. That's how I do it at home. That's how I do it on my personal projects. At work, they make me do it the Google way, which is the other way I just showed, which is what most people do now. Both ways are fine. This looks more, you know, it's more natural to me because it's what I'm used to. So what I'm going to do is air equals -1, grass equals 0. How about rock equals 1? So we can add any number of blocks. Well, not any number. We can add up to 2 point whatever billion, whatever integer max is. But we're not going to do that. We're just going to have air, grass, and rock. I'm going to get textures for this in real time later. Equals new block. So we're going to I need a getter and setter for that. Private int type equals that. Actually, I'm going to make the x and the y public because this is kind of like a vector anyway. I'll keep the type private. Public void set type int new type. Type equals new type. And then we need the getter. Public int get type return type. Okay, so now our blocks each have a type. So initially we're going to make all of our blocks either air or rock. Should I do air or grass? We'll do air or grass. How about that? X, Y, and Z. We're going to do a new block, and I don't have it in the constructor. That's fine. I need a Z position. This.z equals Z. Okay, now our constructor is complete. So it's going to be I, J, K. Now we've created a new block. Now we're going to set the type. We're going to have two different types of blocks initially. What I added this fourth parameter for, which I didn't finish, int. How about ground height? So the ground height, if we're going to have an array like 10 by 10 by 10, we can set the ground height to 5, and that will make the bottom 5 layers all grass or whatever, and it'll make the top 5 air. So that's what we're going to do. So we're going to do if ground height is less than or equal to y, because y is the elevation, blocks, was it x, y, z dot set type, and that type is going to be, what did I say, grass is 0. Do that. Else, even though I don't have to put it in braces, I will. Blocks x, y, z dot set type of air, which is -1. Actually, what I can do, the type is already -1 by the constructor, so I don't even need this part because that's already done for me for free. Okay, so now we've generated an array of blocks that we can't see. Excellent. What's the next thing we can do? The next thing we need to do is probably show these blocks on the screen. So the first thing I'm going to do before that is I'm going to go look up some textures because I'm doing all of this from scratch. Grass texture. We're not going to go for normal maps yet because we don't really need them. Let's go ahead and get a 256. That's too big. I mean, we can always resize it if we want, but let's get a 256. I don't want to get something too big. 256, 256, go. That's a good grass texture right there. We'll use that one. View image. And it's seamless. Perfect. That's what I like. Oh, I copied the URL instead of saving it. Sorry. Alright, where do I want to put this? Not in the F drive. Yeah, let's put it in the F drive. Downloads, that's fine. Grass.png. Get in there. And we're going to go rock texture also. Rock texture. We're also going to get the same image size. Oh, it's already there. Let's see. Where's a good rock texture that looks like that? That looks kind of good. We'll use this one from Bundysoft. Save. Rock.jpg. That's fine. Okay, so we don't need that for now. And I'm just going to go ahead and find these on my computer and move them over. You can initiate a Java array without dimensions. Did I do that? Oh, you can, but you'll get an error doing what I just did. That's a good catch. So we're actually going to do, what are we going to do? We have to initialize it here. So we don't need this, because that won't do anything. Blocks equals new block. And it's going to be x big and y big and z big. My viewers always have these unpronounceable names, and I want to say your names on stream, but I know I'm going to get it wrong. Thank you, Jakaryun. Thank you for catching that, because otherwise we were going to hit an exception when we get down here. We were going to hit a out of bounds, I guess, because it'll initialize them at 000 if you don't specify, I think. I think that's what Java does. So I'm going to move this around. So nope, wrong drive. We're on the F drive. Downloads. Grass and rock. We're going to just drag these guys over here. Whoops. I need to open this up first. Project assets, textures. We're going to drag these guys right in here into textures. Easy. Close. Alright, well, okay, I don't need that line of code actually. Alright, so now we've got our block grid. So now what I want to do is probably in my main method, although I could probably do this anywhere. We need to make a block grid that we're going to have just in the program. Grid equals new block grid, and we're going to make it 16 by 16 by 16 and the 8. Is there something I want to do on that? Well, we're not generating any nodes yet. When we actually get to putting the things in the world space so we can see them, I'm going to have to generate a bunch of nodes with geometries. We're going to get to that in just a minute, but before I do that, I actually want to do one thing. I want to add a light to the scene. Because if you don't add a light to the scene, then you can't see anything. So light equals new light. It has to be a specific type of light. That's an interface, I believe. So we're going to do new ambient light. Now let's do directional. So a directional light is a light from an infinite distance away that just points in one direction. So everything facing a certain direction gets lit up. That's what we're going to do. Root node dot add light. And I believe the color is already white, but I need to set the direction. What's it want to do? Searching for suggestions. I believe it's set direction, but it might be something else. I'll just guess. I'm going to guess that it's set direction. New vector 3f. A vector 3f is a three-dimensional vector, if you know, pretty straightforward. And this vector is going to be pointing straight down and at an angle. So let's see, 0, -1 means down, -1.0 means down, and then we'll do like 0.2. Oops. So that's looks like it worked. It's not giving me any compile errors. And I wish I had kept that other box in here. Oh well, that should be fine. So if I run the scene, we still won't see anything. The light will be in the scene, but we haven't actually added... What is it doing? Classpath scanning. Is there any way I can... What is it even doing? Yes. Yes. Run. Ugh, crap. Alright, I think I'm just going to restart the IDE. because it's complaining and it's not going to run anything. I don't care. Okay, we'll start it up. Where is it? The stream's still picking it up even though it's no longer there. That's interesting. Long live Java as the IDE. It didn't actually crash. It was just waiting for an operation that wasn't finishing. All right, there we go. I probably have to toggle this. Okay. It's still scanning. Okay, it's scanning projects. Looks like it's going to be done. Update found. We can skip it. I'm getting a compile error here. Maybe. What is it doing? I closed all these projects. I'm gonna run it and see if it complains. Let's clean and build. Is it like looking for JMonkey? Let me see. Libraries, the JME libraries are in there. We're using 1.7, which is fine. We don't need Java 8. Everything that should be in here is in here. I don't know what it's doing or why it's taking so long. I guess I could, do I even have Eclipse on this machine? I could move to Eclipse, but then I have to set up the project again. You know what, maybe we'll, let's just keep going and hopefully it'll finish, and if it doesn't finish, we still have a lot that we can code. And I can do most of it without actually running the game, because a lot of early game development, you don't actually get to run anything, because your engine's not done. Like, you just can't run it. There's like a large amount of code you have to write just to get something that works at all. And so we can write the parts of the code that we need first, rather than just trying to run it. So the next thing we're going to need is we need to show these objects on the screen. And we're going to use quads, which are flattened squares geometry. They're flattened square geometry. And we're going to use cubes. Are they called cubes? No, they're called something else. They're boxes. We're going to use boxes, which is a cube. How do I want to do? I think I'm going to do it in block grid. I'm going to give this class our little world thing. I'm going to give it a method that's going to return a node. A node is anything in JMonkey that you can put in the scene. Generate, actually, how about render blocks? So it's going to take no parameters. All it's going to do is it's going to go through this entire array, and it's going to figure out where each block is and what texture needs to be put on it. So for, how do I want to do this? I'll do XYZ. For int x equals 0, x less than blocks.length, whoops, x plus plus. I could have made, well, a three-dimensional array is pretty simple, and it's not like you can change the size of the world anyway. I was about to say we might have wanted to turn this triple array, we might have wanted to turn it into its own object to make it easier to handle all this array notation, but since this array is never going to change once it's created, I mean the size of it, we don't really need to do that. A three-dimensional array is fine. But if you're doing something that changes in size, you might want to use one of the collections, like a list or a map or something like that. So, and then for int y equals 0, and we are going to do optimization as well. So the initial run that we do, if this thing ever finishes what it's doing, which it probably won't, the game's probably going to run really slow because it's not going to be optimized. So one of the things we'll do in a future date is, let's see, it's going to be blocks x dot length, and then y plus plus for int z equals 0, z less than blocks xy dot length, z plus plus. Okay, so all of our code's going to go in here. Triple nested loops are weird, but sometimes you need them. All right, so if this block is air is -1, like I said. You know what? I should use constants. Let's stop being bad and let's start using constants. Private final static int type air equals -1. We're going to copy this. Type grass equals 0 and type rock equals 1. That's all we wanted. Save all that. Equals block.type. Oh no. Did I make it public? Why not use an enum? Because I don't want to. This is fine. One of the advantages of enums is that you can give them properties. Like, you can give them properties and even functions, but we don't need to do that. Like, these can just be constants. I could have used an enum, I just chose not to. I don't want these private, I want these public. Your constants, if they're going to be used by a lot of things, they should probably be public. And they should even be in their own class. There we go. But these constants really only apply to blocks, so I'm keeping them in the block class rather than making a separate class for all my constants. I'll probably have a separate class for my constants at some point anyway. If it's air, we don't need these brackets. If it's air, then we don't render it, we just continue. So we're not going to render the air blocks. Self-explanatory. Otherwise, we don't need the actual else because we have a continue on. That should be on the next line. Otherwise, we're going to render this block. And we're going to do it the most basic way possible. Every block is going to be rendered as a cube, or as a box, rather. I should probably write a convenience method for this. Let me go to utils. Actually, no, it can be here because it pertains to block. Well, yeah, it can be here. Public. What do I want to do? Node, box. It's going to end up being a node anyway. Node, make box, int type. So what this is going to do is this is just going to generate a box and put a texture on it based on the type of the cube. If type equals block.type air, return null. If I probably could use a switch. It doesn't matter. If type equals block.type, we'll just do grass for now. I'm not gonna do rock right now because it's just gonna be copy paste, right, to change the texture. So box B equals new box. This is JMonkey Engine, and we're gonna go 1, 1, 1. Those are the dimensions of the box. So it's gonna be 1 unit by 1 unit by 1 unit, because again we're on a grid. We're on a grid space. This is what we want. Geometry G equals new geometry. This is just how you give things shape in JMonkey Engine. A box is like a template for geometry, and the geometry actually builds it. So we're gonna, I think we have to give them a name and then put the box in there. This is really bad variable naming. Let's do that. And one thing I'm gonna do for later, actually I'll do it later when it's relevant. It's not relevant right now. And then materials are how you apply textures and shaders to things. So equals new material, material. And JMonkey Engine has quite a bit of them. Let's go back to the JMonkey Engine website. They have a wiki that has a lot of good information on it. I've learned many a thing from this wiki. You go to, they have a material definition page somewhere. Is it intermediate, I think? Advanced documentation, maybe? Material. Not that one. How to use materials. All material definition properties. This is the page I use. So each of these things on the left on this grid is a material. So there's a material for the sky. These are like the pre-made materials that come with the engine. You can make your own, but these are pretty common. So you have one for sky, you have one for terrain, you have all this other stuff. Unshaded is probably what, yeah, actually no, we're not going to use unshaded. We'll do normal mapping later. We'll use lighting. Lighting is what we want because it's going to make it look real nice. New material. Asset manager. Oh crap, that's what I need. I need a way to feed the asset manager to the block grid. Yeah, I'll do that later. Common mat defs lighting. I think that's what it is. I've done it so much that I pretty much just know it. Common mat defs. Oh, lighting. Lighting.j3 material definition. That's what it stands for. mat.setTexture. This thing's still scanning my class path. That's going to be really annoying. I guess the first time I'm going to run this is the next show, which will be next Tuesday. This Thursday is an odd Thursday, so I don't do shows on that because I'm lazy. So the next show will be Tuesday, and then that next Thursday is also a show. So that's we'll probably be able to finish this in 3 episodes, I hope, if I don't talk too much. Set texture. We're going to set the diffuse map. This is the texture map, like the regular texture that most people think is a texture. And then asset manager dot load texture, and the texture is textures. It's these guys up here. So the path is going to be textures / whatever. So in this case, it's grass.png. That's right. We don't have a normal map for this yet. Maybe I'll make one later. And then so the next thing we have to do is we have to give the material to the geometry. Come on, Matt. This is really going to annoy me. I'm going to see if I can stop this. Stop that too. I don't know why it's scanning my class path so much. There's nothing there. Oh well. Alright, so we are setting our material. I think we are done, and we can return this box. Let me think if I missed anything. Let's see, so we make our geometry, and we have applied a texture to it. We need to return a node. Forget that, let's return a geometry. We'll return a geometry. And then, so we're just going to return geom. And then, if nothing else happens, return null. And let's document our code. Convenience method for making a box with a texture. The type of block to make affects the texture. It's trying to search for suggestions when I dot on a comment. Whatever. All right, so render block. So if it's air, continue. Otherwise, geometry equals, what's it called? We'll make it static. Block grid. I should really move this to another method. Dot make box. It's not showing up because it's still scanning my class path. And the type is going to be blocks xyz dot get type. Now I'm going to refactor a few things now. Refactoring is when you move around your code just to clean it up a little bit. You don't change what the code does, you just change how it's structured, how it looks. So the first thing I have to do is this asset manager thing actually comes from the main application, and we don't have access to it. If this thing wasn't stuck scanning my class path forever, it would be giving me compile errors here, and probably some other places, but particularly here and here where this asset manager is. So we need a way to get that. I'm going to create a new class. This class is going to be called constants. Actually, let's call it this constants fine. Let's call it utilities. Maybe we should call it constants. Yeah, utilities is fine. All right, get rid of that. Get rid of that. All right. Private. Is it static? I don't believe it is. Private asset manager. Nope. And is there anything else I want out of here? We're going to move this method there. That doesn't belong in the world. That really should be in here. If this was a bigger game, I would even go one step further, and anything to generate my geometries, my shapes, I would put in either one or maybe even multiple different classes, because it's going to be a lot of code in the end. But since we're only going to be making boxes for now, we only have one method and it's pretty short, we'll keep it in here. So what I want is a public static asset manager get asset manager. It does need to be static, doesn't it? Yeah. Okay, this needs to be static. Get asset manager return am public void set asset manager. So when I start the game, I'm going to use this method, the set asset manager, to make the utilities class keep track of it. So the utilities class, anything will be able to call it and get the asset manager from anywhere. This is one of the mistakes that I made in one of my other game projects. Is I made the asset manager just I just kept it in the main method, or the main class. Actually, it inherits from simple app. But anyway, I was just passing it with methods like all the time. So like half the methods in that project had an asset manager as a parameter. That's not what you want to do. So we're going to move it to this utilities class. That way, whenever we need it, we can just get it. So am equals asset manager. Easy. And so on our block grid, whoops, oh right, I moved the code. This is let's give it a proper name. This dot asset manager. This is one of the weird quirks of Java, is you can have the variable name twice in a constructor like this, because one's for this and one's for this. This one's for this. I don't know why they allowed that, because even though like you learn this pretty quickly, it's still kind of confusing to look at. And you see a lot of constructors that just do this dot something equals something, this dot something else equals something else, just for endless. All right, so we can make our box, and this is returning a node. We need a node to actually return, and the node, we don't need to name it. Node.attachChild. This is how you put things inside a node. We're going to attach the thing we just made. So the geometry here, this is the box. This is one block of the world that we've put a texture on based on its type. It already has a, oh, we didn't give it a, yeah, we did give it a position, did we? Oh, we gave it a position up here. Yeah, the IJK. Yeah, we already gave them positions. That's fine. So they have a position, and we gave them a type. This just turns the type into a texture, and then we attach it to the geometry. However, one thing that I just missed, geometries don't know the XYZ of our blocks. So we have to do set local translation. This just sets the position of it relative to the parent. So the parent node, the one we're returning, is not going to have a position. It's just going to be 0, 0, 0. So this is going to be the position of the block in the world. So it's going to be XYZ. Actually, am I allowed to do that? It's not going to, oh, can it not find, it should be able to find JMonkey. They're all right here. It's still scanning Classpath. Oh, God. I really want to force kill that. Give me a second. Maybe I can. Loop. Let me see if I can just get rid of anything that's Java that isn't JMonkey Engine. Alright, I've got 2 JMonkey platforms open apparently. One of them, I'm going to guess the one that's messing with me is that one. Let me just scroll down and see if there's not another Java thing running, because probably I can close this now. Let me see what I got. Let me see if I can fix our problem. I'm going to close this. Okay, all my stuff's saved. I'm going to close this and see what happens. That was not the correct one to close. We're going to close this one too. We'll close both of them. Okay, both of our JMonkey engines are closed. Maybe that was the problem. We're going to try it again. OBS goes to the bottom right corner when it does that. Alright, that's interesting. Alright, so let's see what it does. Oh god. Background scanning of projects, it's going up, it's at 100. Aha! We have done it! I have fixed the problem. Alright, so we need to import all this crap. We're going to hit OK to whatever it says. Set direction, I guess it's not set direction. It's set... It is a new light. Okay, now we can set direction. What does it want now? No suitable constructor for vector3f int double float? Oh, come on. Okay, we've fixed that. Let's go over here. What's it going to tell me? Blocks xyz dot set type semicolon. Node equals new node. Import that thing. Geometry make box. Is this not public static? Where did I put it? Utilities? Oh, right, because it's not in block grid anymore. It's in utilities. I fixed it. All right, we're going to import everything. Nothing to import. Is this public? Public static geometry make box. We're going to import all this crap too. Having import on a shortcut is so helpful. What was it complaining about? Accessing static field. Oh. It's good convention when you have a static method to always call it with the class name, even if you're already in the class. Because what I had was basically, you know, this dot asset manager. This would be good normally, but if it's static, you really want to associate it with the class and not with an object. And actually, just to make sure, we're going to make this abstract. Abstract means we can never create an instance of it. So utilities is only going to be static variables and static methods. And then it's expecting return variable, and it doesn't have one. Return node. Okay, all of our compile errors are gone. Now I can actually run the game. We still won't see anything, but let's just see if it runs. It should. Did I hit run? Yeah, I hit run. It's probably building. If it takes more than 20 seconds, I'll kill it and try again. Sometimes it gets stuck. I guess it got stuck. We're going to stop it. And we're going to try again. Oh, it's building. I've got 2 runs. Alright, let's just stop both of them. This thing just does not want to cooperate with me today. Oh boy. Well, we're going to let it close. We're going to let it close on its own. We don't need that light import anymore. Alright, so we've got our utilities. We can get our asset manager. So down here, we're going to get... wait, where did I put it? Oh, it's in the same class. Okay. So this really should have a utilities on it. Is it private? It's private. Static asset manager, get asset manager, return asset manager. Easy. What do you want? Public static asset is already defined? Oh, wait, what? Oh, it is already defined. Derp. We don't need that. Oh god, that's so annoying. I'm going to have to fix that sometime. It's not going to be today, I guess. Alright, so what have we done so far? We've made our grid. Our grid populates the world with blocks. A lot of them are air, and the rest of them are rocks, based on their elevation. And we have some code that here we generate a box with a texture. And in here we put it in the world. So what I'm going to have is simple init app. We've created our grid by calling it up here. This actually just happens when the program runs. And then in simple init app, we're also going to do node world node equals. Actually, we're gonna store this up here. New node. Import it. Wrong button. Import it. And get rid of that. World node equals, what is it? Not utilities. It's going to be our block grid, which is grid dot render blocks. So what we should get if we were running it, which for some reason we can't. Let's see if I can clean it. It's not going to cooperate with me. That's too bad.